All right, it's 8 p.m. So let's start. Everybody probably knows me. Luke, the Vice President. I've got John and David here as well from the Executive Committee. Martin is an apology today because he is off. He's away for work. And today we have Tony VK3TC here to give a presentation about Rippletech electronics, and apart from that, also about antennas, balloons, and that sort of equipment in general. So we don't have too many announcements at the moment. Not too much going on, unfortunately. Still, everything's locked down. Tomorrow is, or this weekend is the Oceania Dx Contest. I'll be activating VK3R for that, assuming that my antenna stays up. So I'll be on 40 meters. So I invite you all to participate, and of course there is a club award. So if you're participating in the contest, put your club into the log and let us know, and we can go for the club award. Also, yeah, the repeater has had a hardware fault, also due to the COVID restrictions. Of course, it's a bit hard to get there and repair it. It needs a replacement part, which sounds like that is on hand and will be going in soon. And so VK3REC should be back on the air very soon. Yeah, with that, I'll hand it over to Tony. Thank you for coming, and over to you.
Okay, thanks, Luke. I hope everyone can hear me all okay, and hopefully I can run the presentation too. Hopefully it'll work. Before we get into the presentation here about the Oceania Dx Contest that's on this weekend, if you saw the email, it starts at 4 o'clock local tomorrow, 4 o'clock local, SSB, 160, 80, 40, 20, 15 and 10. If you can submit your log with EMDRC noted as the club in the Cabrillo file, when you submit your entry, then that goes towards the club award. And the local club, like MDRC, Western and Districts, or Central Coast, Sunshine Coast, etc. All the local clubs, it's a bit of a competition to see who has the most entries with more than 50 contacts in your log. If you're worried about that, it's fairly easy to rack up 50 if you get on to 40 in the evening, and perhaps 20 in the afternoon. Long path to Europe. And now with that sunspot number, or the solar flux up above 100, 15 probably should be open to Europe in the early evening. And even 10 meters should there's quite a chance it'll open up to Japan and maybe even the States. So hopefully you can have some fun and actually get on the radio and have some contacts. David's just asked, it's 1600 hours local, so 0600 Zulu it starts, and of course because of daylight savings it finishes at 5 p.m. local on Sunday, so you get an extra hour sort of. Okay, so if you can get on there and make some contacts, even if you don't make it to 50, please submit your log and put EMDRC as your club. All right. So I started Rippletech in about 2004. Just wanted to do something a bit different, and try to provide some products that maybe weren't made in Australia or very easily obtainable in Australia. and a little bit different. I didn't want to sort of go into competition with other manufacturers that were already producing stuff. So I did a bit of a survey, and it looked like most people didn't have a tower, and there was a lot of interest for verticals. So I kind of concentrated on that. I did want to do an automatic antenna switch for Yaesu products, but the investment was probably looking at over 50 grand, and I didn't really want to plow that much money into it straight off the bat. So I didn't take that up, but I did make some remote controllers for the FT1000 MP, FT2000 MP. They probably work with some of the other later model radios as well. But let's get into just some of the things I've done. The first thing I thought I'd talk about was, because people seem to have limited space, is probably the biggest vertical seller I have, which is a 4-bander for 10, 15, 20 and 40. It's about 7 meters, a bit under 7 meters tall. And a lot of people don't have much room. So I asked the question, what if you didn't have, much of a backyard? You're in a small sort of unit type situation. Could you put this vertical along a fence line? Is it feasible? And could you still get a reasonable VSWR and reasonable bandwidth? And what about if your fence was metal rather than the standard sort of wooden fence we have here in Melbourne? And it's not quite as common up in Queensland, but I think in New South Wales still the wooden fences are pretty popular. Some people have those metal fences. And what could you do about that? So I did try it once. This is the actual vertical itself. Slightly been modified since we first started out. On the left-hand side over here is it packed down. I make it less than 1 meter in length so it can be sent by the post. It also makes it fairly easy to pack up and travel with it. This is a 10-meter trap. Here's a 15-meter trap, and here's a 20-meter trap. And then these elements here on the left are the extension for 40 meters. This is the base section. This, for a smaller antenna, it might be 4 millimeters thick. The larger ones are 6 millimeter thick, and I've got some acetal insulators here and a UHF connector at the bottom. A couple of U-bolts that take 50 millimeter diameter pipe. And I've got tapped holes here and here for attaching your radials. This is kind of a look at it looking up, and you can see it pretty much fully assembled. Over here is a picture of the base on a short submast, and I've got 4 radials per side installed on this one, and a common mode choke, just a few turns on a toroid. I've never really noticed terribly much difference with this, with the verticals, but it could stop a bit of feed line radiation. And that probably helps more on receive to limit the amount of noise pickup you're getting on your cable. And over on the right side is just another photo. It shows the installation, I guess, in the middle of the yard. So that's how you might mount it on a pole. You might make that pole way up here and install it higher. You can also mount this on the ground and then just lay any length radials you want, as many as you want, as many as you can, and as long as you can, to improve the efficiency of the antenna. And then this is the diagram of the installation. I don't think I took a photo of it installed on my wooden fence here. But basically I came up with a bit of trial and error. 2 radials per band, each opposed 180 degrees. So 10-meter radial on one side, 10-meter radial on the other. The 10-meter one goes on the top and it's pretty horizontal. Run the 20-meter sloping down at maybe 5 degrees or maybe 10, 15 or 20 degrees for the 15-meter. and then I put the 40 meter running downwards till it gets the bottom rail, and then horizontal from there. The main thing here is to keep the ends separated as much as you can, and that's the same with any fan type dipole as well. There is capacitance between these 2 points, or between here and here, and at the high voltage point, that's critical. What it does is it changes the length needed to get resonance. So if you, for instance, put this 15 and 10 meter radial quite close together, then you'd need to change the radial length, and that becomes fiddly. So the idea is to keep them at least 15, 20 centimeters apart, minimize that capacitance, minimize the impact, and therefore keep the dimensions of your radials stable for each installation. If you want to ask a question or go over something, type something in chat. Hopefully I can see it, and I could cover that topic if you need to. I use PVC covered insulated wire for my radials, 1.5 millimeter squared copper. It's just ordinary building wire that you buy from an electrical outlet. It's pretty tough. It's relatively inexpensive. You don't need the high expensive stuff for radials at all. PVC is going to make it survive fairly well in the environment, and it also shortens up the radials for resonance because of velocity factor is maybe 0.95 instead of 0.98 or 0.99 for, say, bare copper or enamel copper wire. And these are the lengths I use. Sometimes I might go to 10.3 meters for 40 meters because 15 and 40 tend to interact a bit. Best resonance, or VSWR, seems to be achieved when you make this 40 meter a bit longer than it needs to be. Otherwise, the 15 meter VSWR you can't seem to be able to get it down. So this worked. It means you virtually need no space. I had a customer do this on a metal fence, 2 customers in fact, and they just used the metal fence. This was a metal fence rather than a wooden one. No radials required. They used 1 bolt here. They bolted it up. They could tilt it over when not in use, and it was virtually hidden away, and all they did was rotate it on 1 bolt and put another bolt in when they wanted to use it. And they're very happy with that solution. Tom, the efficiency, well, on 10 meters, it's probably pretty close to fully efficient. On 40 meters, you're probably down about 60%, maybe a dB worth of loss. It's 6.9 meters. There is definitely losses in the traps. One thing about this antenna is I've noticed since people started using FTA, that with that constant transmission mode, with full carrier, the traps will heat up. And just in the last month, I've tried, well, 6 months ago, I tried LMR 240 cable, which is lower loss. Didn't make much difference. And recently I've tried Teflon cable, which is about 10 times the price of RG58. And that had significant improvement. Like, you could transmit 200 watts constant carrier and not detect any heating. So the problem wasn't so much the heating. The problem was that when the RG58 cable heated up, the properties changed, and it changed the resonant frequency of the trap, which changed the resonance of the antenna. So it seemed to have solved that now. Hi, Jack. Over a metal roof. That's how I test them. I put them on top of the garage. Works very well. Ideal. I think a big garage ground plane is the best option. Gives the best efficiency of the lot. I think there was another question before that too. haven't got much room. Can I move that to see the cancel permission for aerials? For this vertical, I don't think you'd really worry about it. It's too small. If your neighbours complain, what I'd be doing is sticking it in a probably 60mm tube and making it look like a downpipe. But I think you would just, for a vertical like this, if you ground mounted it, I think they could. I don't think you could. The council could stop you from doing that. It probably wouldn't be as high as your roof, so they'd be hard pressed to force you to do that and take it down. Stick it on top of your roof. You probably have to meet the 3 meters, no more than 3 meters above the roof line. So they could get you if you stuck it on top of the roof. That's the council's, that is. All right. Next, so what did I find out of that? It's feasible, yes it is. The VSWR, I got matches of 1.2 to 1. Maybe the worst case was 1.5 to 1 on the mid bands. So 15 and 20 were tougher to get a good match than 40 and 10. 10 meters is quite broad. You can get the whole of 10. 15, maybe 350 kilohertz. 20 is maybe 250 to 300. And about 100 to 150 kilohertz on 40. The metal fence worked very well. Customer was really happy with it. The radial idea works on the wooden fence, and I didn't find any sort of issues with that arrangement that I'd did here. If I tried to go 10, 15, 20, 40, or put 40 on the top, it seemed a bit problematic. So doing it in this order seemed to give me the best results. All right, let's have a look at another idea is a bit of a fan dipole. I have done a couple of these. I get quite a few requests from customers for specials, which is good and bad. It's good for having a bit of fun and experimenting. It's bad because it takes ages. Can take a lot of time. You think something's going to, just a slight tweak to an existing product and it'll be all good and you'll get it done in an hour. And 10 hours later you go, why am I doing this? Because you're earning $4 an hour or something. But this concept kind of works. Diamond do a similar thing to this with their product. They have a 10, 15, 20, 40, 80 that they do with 2 legs. 1 trap in one leg and 2 traps in the other legs. This was one, just to note this capacitive effect here. So if you're building your own fan dipole and you're wondering why you cut it to length and you don't get it resonant where you want it to be resonant, this capacitive effect will be at play. So I would try to keep these, insulators, the endpoints of the antenna, at least 2 meters apart. Once you start getting them close, then you will find you get the capacitive effect and you've probably got to shorten the antenna, which might be fine. But when you get that capacitive effect, if there's wind and these things fly around, you'll see the VSWR changing all over the place. And for these multi-band antennas, I think 1 trap per leg is pretty reasonable. You don't tend to get too much losses and you won't notice too much inefficiency, maybe half a dB or so. But beyond that, the middle band, if you've got another here, let's say this is 30 and you put a 40-meter trap here, this middle band, the 40, gets quite narrow and the VSWR can be a bit tough to get down. The highest frequency, like 30 meters in this instance, seems to be okay, and 80 meters will suffers from the fact you've shortened the antenna. So it's naturally going to have less bandwidth. There's a couple of comments. Yeah, councils will allow up to 7 meters for a mast. But if you've got something attached to the roof, it's typically 3 meters from the councils above the highest point of the house. You can have up to 8 meters, I think it is, self-standing without needing any permission. For most councils, each council, of course, has got their own. Yeah, okay, Peter, sure. 1.5 to 1, you're going to get some losses, depending on the quality of that transmission line, of course. I presume you're probably talking about RG58, the highest loss. The higher the efficiency of the transmission line, the less the VSWR degradation is going to create. Okay, so I've done these sorts of things with maybe a 20 meter trap here and an 80 meter element and a 40 meter on its own, that sort of thing. Seems to be okay. So let's move down. I've tried, this is kind of a roughie of, I think it was a 40-80, trialing it with a coil rather than a trap. And that coil needs to be reasonably large inductance for 40, maybe more than 80 microhenries. The interesting thing I've learned about this technique, it does provide good bandwidth. You get better bandwidth than with a trap. And you can, if you put a very large inductance here, then of course you can make the lower band you're using the antenna on fair bit shorter. So it's for limited space, that's probably the way to go. What I also found is that the amount of inductance you've got here impacts the length you need on the highest frequency. So the first frequency used, this might be 40 meters. If this inductance was, say, 120 microhenries, so quite large, then that length of that first element would be probably right on a normal length radiator, say with PVC covered wire, maybe 9.85 meters per side. If this inductance is, say, half that, say 60, you will still get some choking effect. But to achieve resonance on 40, that length goes out from, say, 9.85 out to maybe 11. And I found this mostly with doing the 17 and 40 meter rotary dipoles, aluminium ones, where the coil that I use in the aluminium is enamel copper wire. It's about 43 turns on a 25 millimeter former, and it's, from memory, I think it's about 18 or 20 microhenries. It's sufficient to choke it off on 17 meters, but rather than being 4 meters per side, it's about 4.5 meters per side required to achieve that resonance, which works out to be quite good, because 4.5 meters per side turns out to be good for 6 meters, and the choking impedance of 20 microhenries is heaps at 6 meters compared to 17, so it's a bit fortuitous. But that's an interesting thing. So if you're making your own using this technique with a coil here to choke off the first band, the highest frequency, and then another bit of element to bring another frequency in use, the size of this coil makes a difference to the length that you need for the first band. And of course it does for the second band as well. But you can't just cut it to, go look up the book and say, okay, for 40 meters, I need 10 meters per side, and you put your coil in and you're nowhere near resonance. So that's something to consider. Okay, is there any other questions? So, Russ, hi Russ, good to hear from you. Says, I guess everyone can see the chat, so Russ's comment there about the state building regs. Yes, well, with the radials, yeah, you'd have to take into consideration if it's installed on fence there, your EMI safety considerations. Certainly, as far as zapping a possum and a cat, well, don't care much for either, but yes, care of the animals, I think it would be a rare instance, but I'm using PVC, so maybe if they jumped on the antenna, they might get a burn and then they would just jump off. Don't think it would be lethal, but they might get an RF burn if they touch the antenna while you're transmitting. They'd feel that after a few seconds and jump off, I'm sure. Okay, this is another version of one of those coils. This one, I wanted to use at a higher frequency, up 10 meters or 20 meters, and there was not enough inductance here to get it to work right. So this may be probably 10 microhenries, maybe. Maybe that's enough for 10, 15, maybe. Certainly wasn't enough for 20. So this technique I kind of like, with the holes, means that with strain relief this works rather well, and the crimps, but I need to have much more of coil here to work on 20. This might be repurposed for a 10 meter 15 or 10 20. That was the other thing I should mention, is that if you're trying this technique for 2 bands, using this coil to choke off the higher frequency band, you can't really, the lower frequency band you're going to use should be at least half of the frequency of the top band. So if you're working on 10 meters, you want to use this and choke it off on 10 meters. The other leg, it's best to maybe try to aim for 20 meters. If you try and aim for 15, this second length is going to be very short, and the tuning on that is very critical. You cut off 5 millimeters and it moves half a megahertz sort of thing. But if you have, say, 10 and 20 or 12 and 30, then this technique works quite well. 40 and 80 works okay. But if you tried 30 and 40, you might make it work. Well, you probably will make it work. It's just the tuning on 40, getting that length will be quite touchy. So that was another thing I found. So when I do these, I tend to use, say, 10 and 20 rather than try to do 10 and 15 using this technique. Luke asks about, tuning. Yeah, I will always make them long and trim. It takes longer to do, but the other option is I do pre-stretch all my dipoles. So all these copper wire dipoles, I tie them up to a post and stretch them. One technique is to, and that hard makes them hard drawn. And then they won't stretch as much when they're in the air. If I put a whole lot of strain on them and really pull them till I feel that they're not going to move many more, then you can't lengthen the antenna any much more. The other technique is to maybe go to 80%, and then if I cut it a bit short, I've got a little bit of wiggle room to give it a bit of a yank and stretch it a bit more to get the resonance where I want it. The other technique is to put a fly lead here and have that dangle down, and then you just trim the fly lead. If you think about, let's say this side over here is the 40 meter side, let's say, and over here was your 80 meter side taking off to the end of the antenna, and over here towards the bellon. You could put a fly lead here on 40 meters. If this choke was big enough, it would look like a really high impedance at 40, and the rest of the antenna is not seen. And you hang a fly lead off this point here, and then trim that up to get resonance. In some ways that might act a little bit like a capacity hat, but that's a technique that I now use with the trapped dipoles to make it easier to tune, rather than, and what I tell people to do is fold the wire back on itself, and then if you put it in a different installation, it needs to be longer, you just unfold the wire. You don't have to cut it, you just fold it back on itself. Anything else? Anyone else asking any other questions? Oh, okay. Here's some of the traps. These are actual coaxial traps. I've got a series of them here. This is a 40-meter trap, a 30, 15, and a 20. PVC covered, well, heat shrink covered, M6 bolts, stainless steel. They got more airflow through them, so they tend not to heat up like a solid former does. And with one trap per side, it's pretty much okay. I haven't had that same issue on the 40-80 traps as I do on the trap vertical. But using the much more costly Teflon RG400 cable would see the efficiency of these traps rise quite significantly. So just a picture of these traps, I guess. And this is what a the 40-80 would look like with traps. And this is the 1-to-1 bell, I think I may have made approximately 500 of these, somewhere in that order. They're a linear type, not a toroidal type, and I've had a few failures, but maybe out of 500, 2 or 3 failures upon build. And I've had my own up there for probably the best part of 10 or 12 years, 15 years, and still going strong. So with this heating problem I had with the traps, noticed mainly with FT8, we started to notice this with a higher duty cycle and full carrier. The traps would heat after 5 or 10 minutes or 15 or 20 minutes, depending on how much power you're running. And then that would expand the cable, that would change the capacitance, and then the VSWR would slowly drift. And then they cool down and they would drift back to where you had them. So without traps, this problem goes away. So that's where these coil-based isolation techniques work. No VSWR drift, far lower losses than in the trap. I don't find the wire heating up. The thing about having the coil, if you're shortening the length of the antenna so you can fit it in a smaller space, having the coils out further towards the ends of the antenna improves the impedance that you're driving it with. The current at that point in the antenna is far lower than it is in the middle where you're driving it, so therefore the losses are lower. Remember, the losses are related to I squared R, so the lower I, the less losses you'll see. The verticals, that TZV4, so we just got a question coming about guying. It's pretty well self-supporting. You support it well enough at the base, it'll be fine. Any of the other taller antennas, I would recommend guying them. I've done a 30, 40, and 80 at one point. I've got a 20-40 that is about 8 meters tall, and I would suggest guying that. But only once. I'd put the guy around about the 5 meter point. Guying twice could mean if you pull down too tight, you can bow the antenna, and I find that one guy with antennas that are only about that tall is better. Maybe if you've got antennas that are 14 meters high or so, the 2 would be better. But with relatively short and you want it a bit more stable, I'd go with one set of guys. And you don't need to pull them down tight, because you just put a lot of strain on the actual element itself and you can make it bend. Okay, so the gains with having these trapless dipoles is better bandwidth, smaller than full size, but still highly efficient. A little bit more troublesome mechanically to build with the wire element, which I'll show you in a second. You can do a 10, 15, 20 meter version, 12, 17, 30 for WARC, maybe 12, 17, 40 if you want. And if you put the supporting element, let's see if I can go down to next, this photo, this drawing here. If you put a coil here and then another bit of wire, you could get 4 bands out of this. So you get a transmission line feed. This actually radiates this part here, forms part of the element, even though it's like a transmission line. Balun here, you can see this one was for 12, 17, and you can see that it's 4.5 meters to this coil. And that's because of this effect I spoke about earlier, where this coil, if that was a really large coil, a really high inductance, 30 microhenries, then this might be back down to 4 meters. But with say 18 microhenries, the element's a bit longer. What that means is the whole thing is a bit longer on the lower frequency and it's a bit more efficient. So if you want a really short antenna, make this coil a lot bigger. So, perhaps you could put a coil here and have this, an extension here for 30 and extend this out for 40 meters, and you could have 12, 17, 30 and 40 in the one antenna. And, it's probably another meter on, maybe you'd make this coil a bit bigger for 40, and it might be, say, the same size as a 20 meter full-size dipole for 20 meters. I've done a few of these. The mechanical problem is just making this wire strong enough. You can use this as a support. The other option is to run this below the antenna, and then birds don't sit on here, or maybe don't try to eat it. That's the problem I find. There's more, a bit of strain here. Maybe the wire might fail at this point, and birds seem to attack it when it's on the top. But for efficiency wise, this is a darn good, simple way to go about it. And it's maybe 1 S point difference between this sitting on a 4 or 5 meter pole on my chimney compared to my TH6, which is on a tower that might cost 20 grand nowadays. So in terms of bang for buck, these are pretty good, especially if you're not interested in putting up a tower in your backyard, but you might have the ability to bolt something to the house and have a chimney or whatnot. And Luke, yes, it's reflected. That's just one side of the antenna. Of course, there's the mirror image on the other side. And this 500 millimeters, you could make that 750. Wouldn't go under 500, I think. Again, you've got to make sure this distance here is, probably 20 centimeters or more. Otherwise, this high voltage point gets capacitive effects. And then depending on how tight you make this, it moves a bit and it changes the resonance. So these tri-banders, that's a full-size element, and that's a full-size element. So 100% efficient for the 2 high bands. Maybe 80 to 85% efficient for the lowest band, this band here for 30. The current distribution on 17 meters, of course, will be a nice half sinusoid, pretty similar for 12, and it'll be linear. And you can work it out, the efficiency, based on having a linear current distribution. So it might look, the current distribution might look like that, and then slope down 2 different slopes, and you can see the difference by integrating that compared to a sinusoid to see what the efficiency is minus the losses in the coil. But I doubt you would notice anything on air. If it's 80, 90% efficient, you're not going to notice it. But you wouldn't see much difference. I don't think you'd be able to hear the difference. Very difficult to even detect a 1 dB difference in gain. On HF anyway, maybe on VHF, UHF, you can hear that when the noise is you know, basically atmospheric or thermal noise. But for this sort of stuff on HF, not really, especially in urban environments. Same sort of drawing, but for 10, 15, 20, 10 meter element here, 15 meter coil, and the dimensions for 20 meters. Again, a typical resonance of an aluminium dipole of this kind for 15 would be 3.35 meters per side. And you can see we're another 200 millimeters longer due to this inductance not being a perfect isolating effect. The bigger you make that coil, the closer this distance will come to your normal distance for a 15 meter element. Any other questions? Okay. Now this is a bit of a repeat. So these 2-element tri-band lightweight Yagis is what I talked about when we did the Oceania, when we did the expedition to Christmas Island and Cocos Keeling Island back in 2017. They're full size. The wire itself is full size on all 3 bands. So we got, say, a 10, 15, and 20. The 20 meter element has some folded back parts to reduce the space. Use an aluminium boom and then squid pole supports, fiberglass supports for wire. I have made an aluminium version where the support for 15 meters is all aluminium, and then the 10 meter and 20 meter elements are wire. Quite lightweight when you use those squid poles. You get good VSWR. You get much better bandwidth than a TH3 Junior of comparable size. No problems with trap heating. No problems with trap burning out. I haven't done the modeling, but I suspect with full-size elements and no traps that 2 elements on 20 is going to be pretty much just as good as the TH3 Junior in terms of gain, but with much better bandwidth. You know, those TH3 Juniors will get water in the traps. You don't have that problem. The problem we do have is maybe the longevity of the wire. So copper is efficient, but it will fail eventually. Much the same sort of problems you get with quads. We could use stainless steel, which is very strong, will last a lot longer, but it's slightly less efficient. Probably not so much so that you'd worry about that efficiency. Stainless steel is probably not a bad idea. But for a de-expedition, the copper was fine. It's nice and light and easy to work with, easy to tune. So some of you might have seen this presentation before. This is the basic concept of these 2-element antennas. So the squid poles are here and here and here and here. So a full size 15 is going to be about 3.5 meters per side. So really you've got to cater for 20 meters. So you put the bell in here, you run about 1/2 meter to 3/4 meter of transmission line here, out to the ends of the boom, and then run the wire element down to the spreader and then out to the tips. You only need probably about 4 meters, maximum 4.5 meter per side. The 15 meter element runs tape straight to the fiberglass spreaders, and the 10 meter element comes this way towards the center. So the spacing for 10 meters is really average between this distance here to here and this distance here to here. So 10 meter spacing is a bit closer than the 15 meter spacing, a bit wider, and the 20 meter spacing, of course, further. So that works out quite well. I've got wide spacing so that the impedance here is pretty much 50 ohms. No need for a matching unit. Direct drive with a ballon, rather simple. And you've got an aluminium boom. And I've done a version where this element is aluminium and you've got to put a spacer in here and then have an arrangement. The difficulty is this bit here where this 20-meter element gets close to the 15-meter element. It's probably okay with 10 meters that you've got enough so that this distance is more than 15 centimeters. So that's where you've got to make this distance here relatively long so that it's further out by the time we get to here. That's probably the most complex part. Maybe there's a spreader, fiberglass spreader here required to keep these elements apart and keep the tuning stable. If someone decides to put this attachment point way out here, it will change the tuning compared to someone who might put it here. I hope you can see that. And these things worked really well when we went to Cocos and Christmas Island. I think there's quite an ability maybe to make a good product out of this when I get some time to finalise it. This is just another depiction of the same style, but this might be it's all the lengths for the design of the 10, 15, and 20. I modelled this with neck and built it within a few percent resonance, and I just tuned for resonance. So compared to the model, if I had to reduce the driven element by 3 centimeters per side, then I did the same to the reflector, and we seem to get about 10 dB front to back, and the order of 4.5 dB gain over a dipole. Here's a picture of a prototype of one of these trapless versions. So you can see the wire support element here. I think this might be a 1740 or 1730 style. The coil is here, and here's a blow up of low resolution of the feed. So the feed line just comes directly off this element, and the pigtails from the ballon go direct to the same spot. These are acetyl insulators which I manufacture myself. Center support with a cylinder that the elements slide into, and then held in place with the mounting screws. All that stainless steel. Okay, we'll go to, we've been going about 45 minutes. Ballons and unnons. I've been building ballons since 2004. Just a few notes on some of the things. I know people are very popular, the end-fed half-wave antennas. Those 49:1 unnons are very, very lossy. Maybe at 1 to 2 dB of loss. And you just think about 3 dB of loss means half the power is dissipated in the ballon, or the unnon, and the other half is radiated. So if you're running 100 watts, that means you've got 50 watts, if it was 3 dB down, dissipated in that ballon core. It's going to get hot. 1 dB is about 1/10 of the power, I think it is, if I remember. So you're running 100 watts, you're putting 10 watts dissipated in the ballon core. So if you've ever put 10 watts into a resistor and have a 10-watt resistor and feel what temperature it is after 10 minutes, you won't be able to touch it. So what happens is the ballon core heats up, it hits the Curie temperature, and the permeability of the core goes out the window when it hits that Curie temperature, and you will start to see the VSWR change and the ballon will fail. As long as you don't melt the insulation on the wire, it'll cool down again and it'll be okay. But if you melt the wire, you can arc out, and that's the end of that ballon. Just for comparison, the 1:1 trifolia ballons that I make with an enamel copper wire, my measured losses are in the order of 0.05 of a dB. At worst case, maybe 0.1 of a dB. So running 100 watts into them, you might get at 0.05 of a dB, maybe half a watt, 1 watt at most. My dual core and quad core 4-to-1s, which are a parallel series 4-to-1 style, the losses there are in the order of 0.1 dB. I've seen people put pictures up on Facebook of these ballons they're making, and looks to me like they're using PVC coated wire to make their ballon, because it's nice and easy to use the different colors and see which is which. That is unbelievably inefficient. That will not work. You might get a nice VSWR, but people don't measure the through loss, and they don't measure the bandwidth. And the PVC coated wire, I tried it for once, and we're looking at 1 to 2 dB loss with that stuff. So never use PVC coated wire for your ballon or your running. Either use Teflon wire is okay. Teflon wire is good. I use Teflon coated wire for the 4-to-1s, or enamel copper wire. The beauty of the Teflon coated wire is it's much easier to strip, but it is more expensive by a long way. But it's good stuff, and it does the job. So here's a couple internal pictures. This is the 1-to-1. I've got a ferrite core in it. This will cover up to about 40 megahertz. If we reduce the number of turns, it would go higher, but you'll lose 160 meters. So this will cover down to 160. One of the things about ballons is people think, oh, I don't need a ballon, I hooked it up and it was fine. Well, it will, but your transmission line will be radiating. And at a loss for the word, but the reciprocal nature of an antenna, transmission is reciprocal to receiving, so you will receive off that transmission line as well. And what do you receive off a vertical transmission line? Lots of vertically polarized noise. And one of the tests I do, I use this ballon connected to my 40-meter rotary dipole, and I listen to that on 160 with that antenna. And the efficiency, the amount of signal I get out of it is very, very low. But the signal to noise ratio is much better than listening onto the big vertical. And that tells me that the ballon's doing its job, because the feed line is not acting as an antenna. And that's the thing you'll note with ballons. If you put the ballon in there, it stops that, current on the outside of the braid acting like an antenna and picking up current, and therefore transferring it to your receiver. So that's why you need a ballon. And conversely, if it's receiving like that, it's transmitting. So if you've got that feed line running close by something else, it'll be radiating from that point rather than radiating from your actual antenna. You'll get reduced signal, you get lower front to back ratio, get lower front to side ratio. You'll get, the power is not radiating where you want it to be radiating. This is a picture of a 9-to-1. This is a trifolia core, a tri-core design. It's 3 cores fed in parallel and then series at the output, and that gives you the 9-to-1 ratio. Enamel copper wire used on this one, and the 4-to-1 is similar to this, except it's either quad core, where I've got 2 of these cores parallel up per winding, or for the lower power model, there's only 2 cores used, which will do a couple of 100 watts quite easily. You could run a kilowatt into it for a little while, and eventually start to heat up. But it would certainly take a kilowatt intermittent for very short transmissions. I've known customers, I've run accidentally hit this with 2 kilowatts and it's survived. And I've know they've gone off to other places where you can run 1.5K, and these will survive and do very, very well. The probably limiting factor is this connector for this, price of $69 for this ballon. This is just an ordinary. It's not Teflon. It's polyethylene connector. If you put a high quality Teflon connector here, you add $5 or $10 to the cost of the ballon, but that'll be better for power handling. But most, as we don't probably not supposed to run 1.5 kilowatts in this country, probably not all that needed unless you travel across to ZL and run your 1K. This is a prototype left outside. See how it won't. This is an NFED. This is Teflon wire. I tried changing the spacing here and try to make it more efficient. This is a triple core design. I tried triple core, double core, single core. Double cores probably get the best result. Single core gives you better VSWR, but of course less power handling. Triple core, better power handling. Of course, you've got 3 cores to heat up instead of just 1. However, the VSWR, because the length of the turns to get each turn on here is more, the high end VSWR doesn't quite work as well as, say, a single core or dual core. So if you're making these, I would make them with a 2-core and either use enamel copper wire or absolutely use Teflon. The other antennas I make are off-center fed dipoles. Richard TXD, I think it is, did a talk about these. He did a lot of studies into them, and he's absolutely right that whilst I put a lot of turns in the choking inductance for the 4-to-1, a choking toroid, a choker at the output will improve any performance of these, restricting any current in the braid of this feed line. I use the 1/3, 2/3, 20 meters long for the 40 and 41 meters for the 80. And you do see that it doesn't mirror exactly along, the middle of each band. As you get further up the band to 10 meters, it starts to move down, and that's because of the NFET. Again, you've got multiple half wavelengths at 10 meters, and it doesn't. There's only one set of ends, so the resonance might be at, say, 14.2, but it's not at 28.4. It's more like at 28.1. So you don't go 7. If it's 7.1, it's resonant. It's not 14.2, it's 14.1 or 14.150, and it's not 28.4, it's 28. So it's the nature of the physics of the product, but they're pretty good bandwidth on 40, very good in fact, and good gain on 15, on 10 and 20. I've used them on 15. You can tune them in and get them to work. In fact, I was very surprised how well they went. So yeah, thanks, Noel. Noel's comment there, appreciate that. Yeah, that's the end of that. So maybe Luke, I don't know if anyone wants to ask any questions. It's about an hour, and I think you maybe, hopefully, people have learnt something or seen a few of the products that I've made. I've done filters, TVI filters for the TV end, so high pass TVI filters. Remote controls for the FT1000, although I don't have any stock of them anymore. Can you stack these multi-band dipoles on top of each other? I dare say you could. Not tried it myself. Just keep the separation, or perhaps make them installed at 90 degrees to each other. So looking down, it might look like a clothesline if you like. Very much similar to that. Any other questions? Maybe Luke,
Yeah.
if you'd like to jump in and.
Yeah. No. I can. Yeah. I think we can open it up to see if anybody has a question that they want to just ask. So I'll set it so that everybody is now able to unmute themselves if they want,
Right.
and maybe just start off with questions.